So in between the mix of me working on the 296, we're going to get a little bit of footage of the guys and what they've been getting up to since I've been away as well. For now, let me explain the story on the Ferrari 296.
Things aren't looking good for Mat Armstrong, and this time, it's not just another ambitious rebuild pushing the limits. It's millions of dollars, industry scrutiny, and his entire reputation balancing on a knife's edge. Inside his UK workshop sit two machines that were never meant to be fixed outside factory walls. A shattered Bugatti Chiron Pur Sport, worth up to $6 million, and a silent Ferrari 296 GTB locked behind layers of software he can't access. Parts are delayed, systems are fighting back, and manufacturers aren't helping. This is one battle, or rather two, that he can't afford to lose. From BMX to hypercars, the story of Mat Armstrong. In a dim UK workshop, Mat Armstrong stood over what looked more like a wreckage site than a car. A shattered Bugatti Chiron Pur Sport, once worth around $3.6 million, now reduced to scattered carbon fiber and exposed wiring. The project had already been a high-stakes gamble. The car had crashed in Miami, been written off, and later bought back for roughly $1.9 million, only to be rebuilt outside the official Molsheim factory system. Without manufacturer support, Armstrong had effectively been forced to reverse engineer one of the most complex hypercars ever made. Bugatti had refused to supply parts or technical data, turning even basic components into expensive, hard-to-source obstacles. Costs had spiraled unpredictably. Factory repairs alone could reach $1.7 million, and every mistake risked wiping out hundreds of thousands. But you see, it didn't start with million-dollar hypercars. It started with a teenager in Leicester, England, chasing speed on a BMX bike, filming tricks not for fame, but for survival. Long before the cameras captured dismantled engines and carbon fiber shells, Mat Armstrong was just a young rider trying to make a name in freestyle BMX, competing across Europe in places like Germany and France, backed by sponsors that covered travel, but not much else. That world came crashing down in his early 20s after a shoulder dislocation at a BMX World Championship qualifying run, an injury severe enough to end his professional riding career almost overnight. One path closed, another, far more dangerous one, quietly opened. The shift didn't look dramatic at first. Around 2013, Armstrong began uploading videos to YouTube. Initially BMX clips, rough edits, nothing extraordinary. But behind the scenes, something else was forming. He had grown up around engines, learning hands-on from his father, Tony Armstrong, a mechanic who ran his own garage. That early exposure meant he didn't just see cars as machines, he saw them as problems waiting to be solved. The turning point came in 2018, when a crashed Audi TT, damaged, written off, and nearly worthless, became his first real rebuild project. Instead of walking away, Armstrong bought it, filmed every step, and turned a financial liability into a story of his own. It wasn't just about fixing a car anymore, it was about showing the process, the risk, and the uncertainty. That formula exploded during the COVID-19 lockdowns. A damaged Bentley Continental GT project began drawing serious attention, pulling in viewers who weren't just car enthusiasts, but people hooked on the tension of the rebuild itself. By 2026, his channel had crossed 6.3 million subscribers and over 885 million total views, placing him among the most-watched automotive creators in the UK. But the numbers only tell part of the story. What really set Armstrong apart was the escalation ladder. Each new project was bigger, riskier, and more expensive than the last. BMWs turned into Porsches. Porsches turned into Lamborghinis. And then, almost inevitably, came the hypercars. That's where admiration began to blur into controversy. Armstrong wasn't just repairing damaged vehicles anymore. He was stepping into a space tightly controlled by manufacturers who build cars with tolerances measured in microns and policies designed to keep outsiders out. His rebuilds often happened without official support. without factory parts, pipelines, and sometimes in direct tension with the brands themselves. For many fans, this was exactly the appeal, a one-man operation challenging billion-dollar companies. But for engineers, insiders, and even executives, it raised a different question. Where does innovation end, and where does risk begin? By early 2026, Armstrong was operating in a space where content, engineering, and controversy intersected. Each project carried millions in potential value, but also the possibility of failure on a public stage. The audience kept growing. Millions watched, not because the outcomes were guaranteed, but because they weren't. Armstrong's appeal wasn't perfection. It was uncertainty. Every stripped bolt, every missing part, every manufacturer refusal added to the story. Could he solve problems that billion-dollar companies insisted required factory conditions? Or was he pushing into territory where the risks outweighed the reward? Standing between those questions is the same person who once filmed BMX tricks for sponsorship clips. Only now, the stakes are much higher than they ever were before. This brings us to the first deadlock in the Mat Armstrong saga: the Bugatti Chiron Pur Sport gamble. This particular Bugatti Chiron Pur Sport was one of just 60 cars ever built, each leaving Molsheim with a base price of around $3.6 million before options, taxes, and bespoke customization. At its core sat one of the most iconic powertrains ever fitted to a road car, an 8-liter quad-turbocharged W16 engine producing roughly 1,500 horsepower. Developed under the Volkswagen Group era and refined through the Chiron program, the Pur Sport variant focused less on outright top speed and more on agility, with shorter gearing, lighter wheels, and aerodynamic revisions designed for cornering performance. It was the result of years of engineering condensed into one of the most extreme road-going machines ever created. One of those 60 cars eventually made its way to the United States, where it was owned by Florida-based influencer Alex Gonzalez. By 2024, the car had already become a recognizable part of social media car culture, appearing in videos and posts that showcased the hypercar lifestyle. Ownership of a Bugatti is never discreet, especially in the age of online visibility. That visibility would soon turn into something far less glamorous. In 2024, the story changed abruptly. The crash itself was not extraordinary in how it began. Traffic slowed suddenly, brake lights cascaded down the road, and one vehicle failed to stop in time. But the consequences were anything but ordinary. The Chiron Pur Sport was rear-ended, its front end collapsing under the force. Carbon fiber body panels shattered and peeled away, exposing internal structures. The headlights were destroyed, the front geometry distorted, and the airbags deployed inside the cabin. What had been a pristine hypercar was reduced in seconds to a damaged shell. The financial implications were immediate and staggering. Early estimates suggested that repairing the car through official channels could cost nearly $1.7 million in parts alone. When a technician from Bugatti traveled from Europe to inspect the vehicle, the process felt less like an evaluation and more like confirmation of the inevitable. The damage was extensive, and the conclusion followed industry logic. The car was declared a total loss. In insurance terms, this meant the cost of repair exceeded what was considered economically viable. Once declared a total loss, the Chiron entered the standard salvage process. Its title was permanently marked. The vehicle was then sent to Copart, one of the largest global auction platforms for damaged vehicles. At Copart, everything from everyday commuter cars to rare exotics is sold to the highest bidder. It was here that a hypercar engineered with aerospace-level precision and produced in extremely limited numbers found itself sitting among rows of damaged vehicles, waiting for its next chapter. Salvage auctions are unpredictable environments. Some cars are dismantled for parts, others are rebuilt, and a few become high-profile projects that attract public attention. This Chiron Pur Sport became one of the latter. It did not disappear into obscurity after the auction. Instead, it entered a new phase that would draw millions of viewers and ignite debates across the automotive world. Yes, you guessed it. It was going to be rebuilt. in front of the world. But you see, things are not as simple. Owning a Bugatti is not the same as owning a typical car. From the moment a Chiron leaves the factory, it enters a tightly controlled ecosystem. Servicing is limited to authorized centers or the factory itself. Technicians are specially trained, and the tools used are unique to Bugatti. For major repairs, vehicles are often sent back to Molsheim. This system exists because of the complexity involved. The Chiron is built around a carbon fiber monocoque chassis, an incredibly strong structure, yet it behaves very differently from traditional materials like steel or aluminum. Damage to carbon fiber can be microscopic and invisible, requiring advanced scanning and specialized repair techniques. In many cases, factory-level inspection is considered the safest approach. This philosophy is not unique to Bugatti. Other hypercar manufacturers, including Ferrari, McLaren, and Pagani, maintain similarly strict control over parts and servicing. After the crash, Bugatti made its position clear. The company did not support rebuilding the vehicle outside its official network, framing the issue as one of safety and responsibility. The concerns extended beyond structural repairs to include systems like airbags and crash sensors, which rely on precise calibration. Even when components share suppliers with other vehicles, they require Bugatti-specific testing to function correctly within the Chiron's unique environment. In January 2026, Mat Armstrong publicly addressed the situation. It was an unusual move for a hypercar CEO to comment directly on a single damaged vehicle. Rimac clarified that many figures circulating online about Bugatti repair costs were exaggerated. However, his primary focus was safety. He explained that repairing a hypercar like the Chiron outside factory conditions introduces risks that are difficult to control, particularly when it comes to calibration and system integration. At the same time, he expressed respect for the individual attempting the rebuild. That individual was Mat Armstrong, and this rebuild series launched online and quickly drew millions of views. Each episode documented the process in detail, removing damaged components, analyzing structural issues, and attempting to source parts. The scale of the challenge became clear almost immediately. Unlike mass-produced vehicles, where parts are readily available, the Chiron required sourcing from restricted channels, shared suppliers, or custom solutions. As the rebuild progressed, it became more than just a technical project. It turned into a focal point for a larger debate: the right to repair versus manufacturer control. Supporters argued that ownership should grant the right to rebuild, modify, or repair a vehicle, regardless of its complexity. Critics raised concerns about safety, liability, and the risks of attempting structural repairs without factory oversight. The discussion extended beyond cars, touching on broader issues seen in industries ranging from agriculture to consumer electronics. Legally, the situation was clear in one sense and complicated in another. Once the car was declared a total loss and sold through Copart, it became private property. Bugatti no longer owned it or controlled its fate. Armstrong, as the owner, had the legal right to attempt a rebuild. However, ownership did not grant access to proprietary tools, software, or factory support. This created a divide between what was legally possible and what was practically achievable. The technical challenge remained immense. The Chiron is not just a collection of parts. It is an integrated system where engine, transmission, aerodynamics, and electronics are interconnected. Restoring it requires more than replacing damaged components. It requires recalibrating systems to factory-level precision. Roadworthiness involves more than functionality. It includes safety systems, crash performance, and regulatory compliance. For most cars, independent rebuilds achieve this regularly. For a hypercar of this level, the path is far less certain. Meanwhile, Bugatti's offer to repair the car at its factory remained open. What happens next remains uncertain. The car may return to the road, fully rebuilt and functional. It may encounter technical barriers that cannot be overcome without factory support. Or it may remain an ongoing project. But there have been updates. After months of teardown, sourcing struggles, and structural work, Mat Armstrong reached one of the biggest milestones in the entire saga. The Bugatti Chiron Pur Sport successfully started its engine. This happened in early 2026, and it was a critical turning point. Up until that moment, there was serious doubt about whether the W16 engine and its surrounding systems could even be brought back to life outside factory conditions. When the engine fired, it proved that at least part of the rebuild mechanically was viable. But that moment, while dramatic, didn't resolve the deeper issues. The rebuild has continued to face ongoing complications, particularly around parts sourcing and system integration. But Armstrong refuses to stop. And there's more from where that came. Ferrari 296 GTB and the manufacturer roadblocks. Launched in 2021, the Ferrari 296 GTB marked a turning point for Ferrari. It combined a 3-liter twin-turbocharged V6 with an electric motor to produce a staggering 819 horsepower, capable of accelerating from 0 to 100 kilometers per hour in just 2.9 seconds. It was fast, technologically advanced, and meticulously engineered. Yet, the car sitting in Armstrong's garage did none of those things. It didn't move. It didn't even start. From the moment power was applied, the dashboard displayed a single, persistent message: hybrid system failure. Modern Ferraris are deeply integrated systems, machines where software, encryption, and electronic architecture are just as critical as pistons and gears. The 296 GTB, in particular, represented Ferrari's first road-going V6 hybrid, built around a high-voltage system that included a 7.45 kilowatt-hour battery, advanced power electronics, and tightly controlled software. When something within that system fails, it is not easily reset. Access to diagnostics, recalibration, and repair is restricted to Ferrari's own ecosystem. Armstrong knew this from the start, but he moved forward anyway. The car itself had already lived a dramatic life before reaching him. Originally purchased by a private owner based in the UK, it was soon exported to Cyprus. Its time on the road was brief. Within weeks or months, the car was involved in a violent crash, likely in or around Limassol. Reports and footage suggested a familiar but dangerous sequence: heavy acceleration, sudden loss of rear traction, and overcorrection, and then a rapid oscillation of control, often described as a tank slapper, with over 800 horsepower sent to the rear wheels, amplified by instant electric torque. The margin for error was razor thin. Once grip was lost, physics took over. The car snapped sideways, control vanished, and impact followed within seconds. The aftermath was severe. Suspension components were torn apart, structural sections deformed, and the chassis compromised. This was a high-energy crash that affected both the visible structure and the invisible systems beneath. When the car was assessed at an official Ferrari dealership in Cyprus, the conclusion was clear: repairs would be extremely expensive and highly complex. But more importantly, the crash had triggered something deeper within the car's architecture. The 296 GTB's hybrid system is designed with safety as a priority. In the event of a collision, high-voltage systems isolate themselves automatically. Electronic networks shut down to prevent further risk. This is built into the system. Once triggered, these shutdown protocols effectively disable large portions of the vehicle. That's why the hybrid system failure message appeared. By the time Armstrong acquired the vehicle, it had already been deemed uneconomical to repair within Ferrari's official framework. In industry terms, it was effectively written off. But like many high-end salvage cars, it didn't disappear. Instead, it moved through insurance disposals, private brokers, and specialist networks. Somewhere in that pipeline, Armstrong found it. He didn't buy a lightly damaged car. He bought a structurally compromised, electronically disabled hybrid supercar that even Ferrari had stepped away from. For most buyers, that would have been the end of the story. The risks were obvious. The systems were inaccessible. The outcome uncertain. But Armstrong's entire career had been built on taking on projects others avoided. he traveled to Cyprus to inspect the car in person. The reality matched expectations: serious structural damage, missing components, and a hybrid system that remained completely inactive. Still, the decision was made. The rebuild would begin. The early stages of the project took place in Cyprus itself. Armstrong brought parts with him, worth thousands of dollars, and began the initial process of reassembly. This wasn't a full restoration, but a starting point, enough to move the project forward. But just that. Once that phase was complete, the car was transported out of Cyprus. This marked the true beginning of the rebuild. At first, the project followed a familiar path. Panels were repaired or replaced. Structural elements were addressed. Mechanical systems were reassembled. But somewhere along the way, the rebuild changed direction. It stopped being a restoration and became something more ambitious. Armstrong began sourcing genuine components from the Ferrari 296 Challenge, a track-only variant built for Ferrari's single-make racing series. These were not standard road car parts. They belonged to a tightly controlled racing ecosystem. As those components were installed, the car began to transform. Visually, it became more aggressive. Aerodynamics shifted. It no longer resembled a standard 296 GTB. Instead, it became something Ferrari itself had never sold, a hybrid between road car and race car. But this transformation introduced a new layer of complexity. Ferrari's systems are built around precision and consistency. Every vehicle is tied to a specific configuration, defined by its VIN, its parts, and its calibration. By integrating race-derived components into a road car platform, that alignment began to break. According to Armstrong, this was the point where progress slowed. Initially, parts orders had been fulfilled. Components arrived. The build continued. But over time, the supply became inconsistent. Some parts were no longer delivered. Requests stalled. Communication became limited. Eventually, a condition was made clear. The car would need to go through official Ferrari inspection channels before further support could continue. This presented a significant problem. Ferrari's inspection process is designed to verify that a vehicle meets factory standards. But this car no longer fits those standards. It had been rebuilt outside approved procedures. It incorporated non-standard components. Even if every repair was technically sound, the car existed outside the framework that Ferrari recognized. By early 2026, the project had reached a critical stage. Physically, the car appeared nearly complete. The bodywork was restored. The structure reassembled. The transformation was visible. But electronically, the car remained locked. The hybrid system failure persisted. The engine would not start. This is where the story expanded beyond a single rebuild. Online, the reaction split into two distinct camps. On platforms like YouTube and Reddit, debates intensified. One side viewed the situation as a clear example of modern ownership limitations. Armstrong had legally purchased the car, invested time and resources into rebuilding it, yet remained unable to fully operate it without manufacturer cooperation. To them, this highlighted a broader issue: the growing control manufacturers hold over their products, even after sale. The opposing view focused on Armstrong's decisions. By installing Ferrari 296 Challenge components and deviating from factory specifications, he had moved the car outside the system it was designed to operate within. Ferrari's architecture is not flexible. It does not adapt to unofficial configurations. From this perspective, the outcome was predictable. The system was doing exactly what it was designed to do. Neither side fully resolved the debate, and that unresolved tension is what gives the story its weight. The facts themselves are simple. The car does not start. The hybrid system requires Ferrari-level access. Parts supply has reportedly been restricted pending inspection. Ferrari has not issued a detailed public response. Everything else exists in interpretation. At its core, the situation raises a larger question. What does ownership actually mean in the modern automotive world? Ferrari has always operated differently from mass-market manufacturers. Its production numbers are limited. Its customization programs are tightly controlled. Its brand identity is built on precision and exclusivity. The 296 GTB's hybrid system is not designed for open access. It relies on proprietary tools, software, and validation processes. This dynamic is not unique to Ferrari. Millions on the line, no room for error. The pressure didn't arrive all at once. It built quietly, with every invoice, every delayed shipment, every unresolved fault. Inside a UK workshop, Mat Armstrong was no longer just rebuilding cars, he was managing financial exposure that could overwhelm most small businesses. At this level, the numbers stopped feeling real. A single project involving a Bugatti Chiron Pur Sport or a Ferrari 296 GTB was measured in millions, and unlike traditional garages with predictable margins, Armstrong's model remained volatile, where one mistake could erase months of work and six figures instantly. The financial risk began at acquisition. Salvage hypercars were never cheap. A wrecked Chiron alone had reportedly sold for around $1.9 million at auction before any repair work even started. From there, costs multiplied aggressively. Carbon fiber components could cost tens of thousands each. A single headlight could exceed $30,000. Add custom fabrication, specialist tools, diagnostics, and hundreds of labor hours, and total rebuild costs could climb beyond $3 to $4 million, often without factory support, where trial and error introduced even more unpredictability. But the real financial danger wasn't what was spent. It was what might never return. In the hypercar market, value depended on provenance, certification, and manufacturer backing. Even a perfectly rebuilt car could fall into a diminished category without official approval. A Chiron worth $4 to $5 million in factory-certified condition might struggle to command anything close after an independent rebuild. That gap between investment and resale value became a financial black hole. Time added another layer of pressure. These weren't short-term builds. They stretched across months, sometimes years. During that time, capital remained locked, parts delays slowed progress, and revenue depended heavily on content performance. Armstrong's platform on YouTube generated income through ads and sponsorships, but that income fluctuated with algorithms, engagement, and audience retention. If a project stalled, the financial model itself came under strain. The rebuild wasn't just engineering, it was entertainment, and both had to succeed together. That's where reputational risk merged with financial exposure. Armstrong's reputation had been built on completing difficult projects against the odds. Each success reinforced credibility. But at this scale, failure carried far greater consequences. A failed BMW build might disappoint viewers. A failed Bugatti or Ferrari project could reshape how he was perceived entirely. In the hypercar world, perception mattered as much as performance, and one high-profile failure could echo far beyond the workshop. Manufacturers remained in the background, but their influence was constant. Independent rebuilds, especially public ones, introduced variables that the brands couldn't control. If something went wrong, it didn't just reflect on the builder. It risked affecting the perception of the car itself. Access to parts, data, and official support stayed limited, and any future collaboration could quietly vanish. Audience pressure added another layer, with millions tracking each update and judging every decision in real time. On platforms like Reddit, opinions were divided. Some praised the innovation and persistence, while others questioned the risks. This split shaped the story at every stage. One breakthrough could rebuild trust instantly, but a setback often fueled lasting doubt. Legally, things remained quiet but tense. With multi-million-dollar vehicles, liability is never simple. If something went wrong later, responsibility could blur between insurers, builders, and owners. Disputes with manufacturers were also possible, especially over parts, intellectual property, and branding. Compliance made everything more complex, as rebuilding outside factory systems raised concerns about safety standards, legality, insurance, and certification. A car that couldn't be legally driven or insured lost much of its purpose, regardless of how well it functioned mechanically. But at the center of everything Mat Armstrong is doing sits a deceptively simple idea. If you buy something, you should own it, not partially, not conditionally, completely. The kind of ownership that, for decades, defined car culture, where turning a wrench, swapping parts, or rebuilding an engine wasn't controversial. But standing in front of machines like the Bugatti Chiron Pur Sport or the Ferrari 296 GTB, that idea starts to fracture. Because in today's automotive world, possession and control are no longer the same thing. Armstrong's position is built on action. He didn't damage these cars himself. He bought them after they had already been written off, pushed out of the manufacturer's ecosystem, and, effectively, abandoned by the systems that once supported them. In any traditional sense, that should have been the moment ownership transferred fully. The insurer steps away. The manufacturer steps back. The buyer steps in. That's how salvage markets have worked for decades, whether it's a crashed hatchback or a high-end supercar. The new owner assumes the risk, and with it, the right to decide what happens next. But modern hypercars don't behave like traditional machines. They carry layers of software, encryption, and controlled access that don't disappear when the title changes hands. Armstrong can strip a car to its carbon shell, rebuild its structure, reinstall every mechanical component, but still find himself locked out of the very systems that allow it to function. In the case of the Ferrari, the issue isn't missing hardware. It's access to diagnostics, software, and a digital ecosystem controlled entirely by Ferrari. And without that access, the car, no matter how complete it looks, remains inert. That's where his argument sharpens. Because if a product can only fully function with ongoing permission from the manufacturer, then what exactly was purchased? The physical object, yes. The metal, the carbon fiber, the design, but not the full capability. Not the autonomy to repair, modify, or even restart it independently. You own the shell, but not the system. The machine, but not the authority over it. Manufacturers see it differently. Companies like Bugatti and Ferrari don't just build cars, they manage ecosystems. Their argument is rooted in safety, liability, and precision. These are not ordinary vehicles. They are machines capable of extreme speeds and forces, where even small deviations from factory standards can have serious consequences. From that perspective, restricting access isn't about control for its own sake. It's about ensuring that anything bearing their badge performs exactly as intended, under conditions they can stand behind. And that's where the tension becomes impossible to ignore. Because both sides are, in their own way, right. Armstrong is operating within a long-standing tradition of mechanical ownership. Buy it, fix it, and make it yours. The manufacturers are operating within a modern reality where complexity has outgrown that tradition, where software and systems are as critical as bolts and engines. The conflict isn't just about one car or one rebuild. It's about two definitions of ownership colliding in real time. The audience watching this unfold has already split along those lines. On platforms like YouTube and Reddit, some see Armstrong as pushing back against an overreach. Others see a predictable outcome. The debate moves beyond cars, touching everything from smartphones to farm equipment, where similar questions are being asked. When you buy something, do you truly own it? Or are you just leasing access to its full functionality? What do you think? Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.